Hello and welcome to the conversation on elements of a successful and exceptional search experience and how Elasticsearch helped us get there. Thank you for joining me. I am Jaspreet Singh. I'm the Chief Search Relevancy Engineer at IBM. The agenda today looks something like this. So I'm going to start with a brief introduction. Then I'm going to touch upon some aspects of how we started this journey and how we went from a pure relevancy-based search engine that we started with, how we received user feedback. We were pretty big on user feedback. We had a lot of user research, a lot of user interviews. Through the life cycle of the application as well, we had in-app feedback. So we heard a lot from our users. And one of my purpose of this talk would be to take us through how hearing from our users really helped us get that give that wow experience to our end users. Then I'll take you through some of the relevancy improvements that were a result of the user feedback. And then last but not the least, I'll take you through some of the best practices and the lessons we learned. And hopefully you don't make those mistakes just as we did, and you can learn from it. So very quickly, the application and the business case. We're IBM Bluemind is a cloud-based marketing intelligence content management system and a search engine repository. And it's the search engine repository part, which is more related to Elasticsearch. But as we'll see, it's the entire end user experience that really matters. So the application has a 24/7 availability. It's accessible to and is looked at by more than 165 IBMers throughout the world. The users that come to us are multiple stakeholders. They're from finance, from strategy, from product management, from marketing, really cutting across roles within IBM. The content ingestion pipeline that we have on any regular day, we could be ingesting in excess of 20,000 documents. And that gives us an overall corpus of close to 3 million documents. What I'm going to show you right now, or I'm showing you right now on screen, is the final search interface. That is how it looked like. And the rest of our talk would be really the journey of how we heard back from our users and how we got there. And also what we're looking at, there's a lot going on behind the scenes. So as I said, we had a lot of user research interviews. We also are pretty big on design thinking. So there were a lot of workshops, design thinking workshops that we, and as a result of one of those workshops, we heard from our product owner, which was sort of a North Star for us. So we really needed a simple search interface that had faceted navigation that allowed our users to narrow down to the search results by applying multiple filters. And also it had to be able to source search results from across different content sources that we had. So one of the first things we achieved was an on-glass integration, and that's the same screen that I showed you earlier. And there's a lot on this screen. So we have the main search results, as you can see. We also have supplementary search results over to the right side. If a user search for example, Amazon, and we have Amazon in one of our company indexes, it would show that as well. Over on top, we have the facets or the filters that our users could use to narrow down. And finally, we have also metadata about the information that gets shown. So we tapped into the multi-search API feature of Elasticsearch that really allowed us to hit one single API and do all these multiple searches behind the scenes. What we also got sort of out of the box was a really nicely packaged single set of search results, and we didn't have to spend our bandwidth or computation power and write custom code to do all that packing or unpacking. That was very, very convenient for us. One of our user interviews was of this marketing insights professional, and he told us that there are some really important trusted resources. And I would love if the top results that I see are from those specific sources. This was one of the first times that we sort of got into the situation where we realized that not the pure technical relevance, but also the business aspects had to be factored in as well. So what we did was we went back to the user, we sat down with the user, we understood what are the sources that are important for them. And then we used the Elasticsearch feature of field boost. So all the sources went into a particular field, and we were able to apply custom boost so that, as you can see, the important sources like Gartner, IDC, Forrester really came on top, and our user got what the user wanted. Another finance professional, they told us, you know what, I'm really interested in the quarterly reports or results that you have, but it doesn't help me if you're showing me results that are 3 years old or 2 years old or more than 1 year old. Great point. And we again went back, and this was another example where just on pure relevancy, the text-based calculations, we had to factor in the time sensitivity this time. And the Elasticsearch feature that came to our rescue was the function score query. And within that, there are different, without getting too technical, there are different ways we could use it. You could go with a linear one, could go with exponential, but we settled down for Gaussian. And really, if I were to give you a top level overview, was we had this something called offset. So between now and offset, all the search results would be equally important. But as we go beyond the offset until the scale, for example, 180 days, so 6 months. So all the documents beyond the offset and within the scale period of 6 months, they would gradually decay or go down in relevancy and reach the threshold of 0.5. So a report, let's say, I'll give you an example. Let's say we have a report, right? Or two reports. They're identical. We get the same relevancy score. But if one report is published, let's say now, versus the other that is published, let's say 6 months ago, then the relevancy difference between the two would be half. So the report that was published 6 months ago would be half as important. And that is exactly what we wanted. The gradual decay, the tapering was exactly what we got from the Gaussian. And this was one of the very big wins, because we realized a majority of our users were really time sensitive or really preferred reports that were recent in nature, etc. Now, COVID, pandemic, it has touched us all, and our users were also sort of not, untouched. So one of the business analysts came to us and said, "I need a lot of reports related to coronavirus and COVID and the impact. And I know there is a lot of content out there, but I struggle to search, right? What should I search for? Should I search for coronavirus? Should I search for COVID-19? That's my first worry. The second worry is, if I pick one of these terms, am I getting everything that you have?" It was a very interesting problem. And when we sat down as a technical team, we realized there's a lot to this than just what the user told us. For example, we had this curious thing going on with taxonomy, let's say AI, right? So what do you search for? AI or artificial intelligence or cognitive? And then the end user perspective of certain terms, right? One user could look for global, the other may want to look up through worldwide. And then I give the example of COVID. And then we had our own specific terms that we like to use, as industry insights, industry views. And when we got back some signals from searches, we wanted to also push these in. And you know what? The synonym token filter was exactly what we need. And through that one single feature, Elasticsearch feature, we were able to tackle all these problems. And eventually, we were able to broaden the scope of our scores and increase the recall. The sales executive came to us and said, "You know what? I'm trying to search, but for some reason, it's matching, but not matching what I'm looking for. And I'm also seeing a lot of gibberish." And that's when we realized our core content management was based on HTML-based documents, and turns out we were not doing a great job at filtering those out. And that's where the custom analyzer feature from Elasticsearch really helped us. In principle, an analyzer is all about putting in a character filter, then putting a tokenizer of your choice. So, you could get the tokens you're really interested in, and then further applying a token filter. So you can pick and choose the tokens you want and ignore them as well. So that was the first use case that we really benefited from, which was on the HTML field. So we were able to strip out the HTML. We were able to normalize them into lowercase, as you can see from a sample custom analyzer definition, and eventually also take care of stop words. And I'll get to stop words in a moment. I talked about synonyms, right? Now, synonyms also, again, eventually the implementation was through a custom analyzer. So we had to be a bit careful, right? Synonyms usually come from a synonyms definition file. And, if you get into those issues, it's really hard to debug. So, just getting the order right was very important. So lowercase followed by synonym matching, then, filtering based on whether we don't want the stop words or we want this tummy. Now, one of the content authors, when we were talking, said, I know I authored a report, but when I'm trying to search for it and I know the title, I can hit it. Now, again, this was when we realized that some fields are actually more important than other fields and they need special treatment. So title, for example, as a result of what we heard from the content author, we sat down with the technical team and we realized this was a classic case where the title field had to be treated like regular text. It had to also consider synonyms. And then there was the question of English language semantics. What if the user is looking for some variation, some root forms? There are a lot of peculiarities of the English language that can really, cause a lot of problems for relevancy. So the fields feature allowed us to, for example, index one field like title in different ways, and we can pick and choose. We could boost what we wanted. We could even ignore what we didn't want as well. So that was really, really helpful. So this was also, like I said, a classic example where one specific field we were able to treat in a different way or different based on the circumstances. Another example where we used the multi-field was there were cases where we needed a field for text matches, full text search, but we also wanted analytics on it, let's say reporting, etc. And that's when we took that field and we indexed it both as a text and a keyword. And we used that a lot. And that was very helpful to us as well. I talked about stop words, and as we were going on our journey of improving our relevancy, listening to our users, giving them what they want, we started to realize search relevancy is a lot about trade-offs, right? You have to pick and choose, and one of the first ones we came across was the treatment of stop words. That was when we need to decide whether we choose performance or precision. Stop words is, in very simple terms, are very frequently occurring words in English language, like the prepositions or the articles. So words like on, the, is, are. If you want to be precise, you have to consider them, right? If the user is looking for some specific, you can't ignore them. But stop words, they can cause some side effects as well. They are just a lot, right? They can really inflate the size of the index. And also, if the field is big or the document is big, the calculations can be pretty tricky as well. So what we did was we went ahead and we decided to ignore stop words through the filter that you saw earlier for fields that were really big. And for some fields, we went in with a hybrid approach, combination approach. One other thing that really helped us was the minimum should match parameter or the query part. Now, again, we realized if the user started to key in a search term that was getting bigger, sometimes we did not get, or the user did not get what they wanted, and the feedback was not so good. So, for example, the user is trying to enter 5 words, right, in search. The user can only match 4 of those on a report. But due to our criteria, the user did not get the hit back, and it wasn't that good an experience. So one of the things we did was we wanted to be a bit more forgiving. So let's say even out of those 5, 4 matched, we would still qualify that. Of course, that doesn't mean that if the user is matching all the search fields, those reports would anyway come on top. So it did not give us any adverse impact, but it's about casting your net wide. It just also brought in the other reports, and this was useful on some of the ad situations as well. Ad scenarios could be pretty nasty sometimes. One other thing that we heard from our product owner was this requirement to show the list of recommended articles based on what the user is reading. So for example, if you look at the screenshot here, if the user is looking at a report, we wanted to have a section called read next onto a side, which was a set of related reports that the user could probably logically go on to once the user read this. Now, it was interesting, we did a lot of POCs on different machine learning algorithms. Guess what? The more like this feature from Elasticsearch really helped us out. And we didn't have to go through the rigmarole of the entire, machine learning training and feedback loop. And we really got what we wanted. And the feedback we got from our users was fantastic. One other tip that I like to share is it's a very versatile feature, right? You could pick and choose all the fields you want. But, for us, simple worked best. We just set it on the title field and it just gave us the best results that we could want or our users could want. Now, as you could see, we were getting a lot of feedback from the users, and what I took you through was a majority of actionable feedback. But the large percentage of our feedback was not really actionable. Then we realized that in getting the qualitative feedback, we were sort of now starting to miss the quantitative aspect of search relevancy. So people come back to us and saying, search doesn't work, I can't find anything. It didn't help us a lot. And that's when we realized that we had to measure it. We had to measure search relevancy. We had to get a quantitative aspect into it. And that's when we got into this topic of search relevancy benchmarking. And to me, this was pretty important. As you noticed, throughout the life cycle of our application, it was all about taking requirements, improving the relevancy. And search relevancy can be very tricky. One thing you touch and it could, break several other parts of your relevancy query. So it's important you keep track of how you're performing. The regression part is very important, and that's where the relevancy benchmarking really, really helped us. But most importantly, it took us from being a sentiment-driven relevancy to a data-driven relevancy. It gave us a number. We based it off on popular industry, information retrieval field benchmarking called NDCG, normalized distributive cumulative gain. We were able to give a number. We had a UI that we used for this purpose. We had a special set of recruited content SMEs. They were human raters. They rated this corpus that we set aside specially, and we got a number. Our requirement was not to be perfect. We didn't want a score of 100 on 100 for the first time. The idea was to get a number. Now, as soon as we got a number, we could benchmark it and we could track it, and that's exactly what we wanted. And this really, really helped us and gave us a confidence as well to change the relevancy or improve the search as well. And the results were, there. The search experience got better. The feedback got better. We heard good things about our search algorithm. Of course, we were still receiving adverse feedback as well. But the decision we took on going out to our users, user research or design thinking workshop, etc., it just gave us a lot of positive feedback, as you can see on the screen as well. So as we made those changes, it's still a journey. We're still going about changes, as many changes, and that's more on the qualitative side of things. On more technical side, also, it was a great learning experience for us. So I want to take us through some of the best practices that we came across as we went about doing various changes. When it comes to streaming data, and there's a lot of use cases you will come across where you have to transfer bulk. Scroll API, there's nothing better than that. We may be tempted to tinker around with the max result window, but Scroll API is just so versatile and just gives so much control over the results. Also, always back up your data and restore it, the production one. The more your staging is in sync with production, easier time you will have replicating those nasty bugs. Aggregations, as I said, Elasticsearch, one of the core points is not just full text search, but also real-time analytics. And aggregations is one of the top features that we used extensively. But where it also excelled for us was as a tool for dev and debugging. It really saved us a lot of effort. We would do so many checks, and aggregations really helped us. Index schema changes. Now, this could be very tricky. If you're not following the processes, just make sure you are checking in your index. You are making, promoting changes across all the environments you have, and making sure you are in control. Otherwise, you're going to get into bugs that are going to be so hard to debug. Same thing for relevancy code. Before you will know it, you'll be using same relevancy algorithms across use cases. So for regular searches, for email digests that you send out, for APIs that you expose for maybe your third-party users as well. And before you know it, you will end up duplicating your code, and then it's going to be a maintenance nightmare. So as soon as you can, just componentize your relevancy code, just make it common, make it reusable, and you'll thank me for that. And I can't stress this enough, automate as much as you can. The more human aspects you take out of all of it, the more error-free your life would be, and easier as well. Now, some lessons learned as well, right? A lot of fields that you have to define either at the starting of schema or even during the life cycle of schema. You will have some fields that will come in. So some decision points that we had to make was, did we want to index the field? Something you should consider as well. Is stop words a consideration? Is it a big field, so you want to ignore the stop words? Is the treatment of English language important? Do you want to consider maybe root forms or different variations? Do you also want to analyze regularly as regular tests? Do you want to include synonyms? Again, our experience was we always erred on the side of going for more analysis than less. And we could always pick and choose, right? And again, multi-field features that I mentioned earlier, we would always combine these different treatments to a single field and just got what we wanted. Same thing for analyzers, right? We use text when we wanted full text treatment for relevancy, and we use keywords when we wanted either an exact match or we wanted things like aggregations or analytics. But there were a lot of times when the same field required both the treatment. And as I said earlier in one of the slides, it wasn't uncommon to see a majority of our fields that were analyzed in multiple ways. Some more lessons learned. Lazy loading. You would get into a lot of situations where performance will be important. So, take cognizance of this. And if there are results that you feel a user may not be tempted to open up instantly, consider lazy loading them. Load them after some time. Just give the user what they want immediately. Lazy load what you can. Synonyms. I know it can be tempting, but I can assure you it can have a lot of side effects. So always be very cautious, have a strict control over the synonyms you want. Special characters give us a lot of grief. So things like ampersand, underscore, and there are multiple ways. Elasticsearch is very versatile when it comes to handling special characters. What we did was we used a character transformation. So we would regularly transform this character into something else, and that helped us treat this. There was one nasty bug we came across, again, performance bug, when we realized we had to show highlights, right? Then we show the search results back to the end user on the screen. We had to pick out the matching terms. And we realized if the field was big, it took a long time. It was a huge performance issue. But then the term vector feature, when set to position offsets, it helped us. It was a lifesaver, and it was a little tricky to resolve this bug as well. So if you have a big field that you want to show search hits from, don't miss out on that one. And finally, I think the biggest learning that we had as a team was, you can satisfy all the users, or you can satisfy all the users sometimes. You can satisfy some users all the time, but you cannot satisfy all the users all the time. So it's very important for you to understand the point where, going beyond, you're just getting to a point of diminishing search return. So, the approach we always took was, if it works for 85% of our users, that would be our default behavior. And we always made sure for the other 15 it was always an override or a plug or a switch that a single click could take them to a different search experience. So we always favored what was working for a majority of our users. So that's it. Thank you. I really thank you for your time, and I hope this conversation was beneficial as I talked you through some of the experiences, the live real life experiences, how we organically built upon pure technical search relevancy, and how Elasticsearch really helped us. There were so many out of the box features that we got from Elasticsearch, and I just cannot imagine what would it take us if those we had to implement ourselves. So once again, thank you so much.